Hi, Chris Guzmal here. We're going to be talking today about the chain rule. Um, but to get to the chain rules involved in differentiation in calculus. And we're certainly not going to get it all covered in one or even two videos. But let's start off just talking about an example function or two and move towards the chain rule. The chain rule talks about what we call composition of functions. So consider the function x squared, excuse me, negative x squared plus 1, or alternatively, we could read that as 1 minus x squared. So it starts off when x is 0 at 1, and then subtracts off x squared as we go along. And so once we get up to x equals to 1, then 1 minus 1 squared is 1. And so that's how our graph heads on down. We're zoomed in pretty far, but it's basically an upside down parabola, depending on whether or not you view a parabola as default as upside right, which way pointing up, but it's uh, the top of the parabola is right here on the y-axis. Um, so that's a lovely, lovely function. And we're also interested in another function, uh, which is the sine of x. And we're zoomed in pretty close. Normally we think of the sine as being something that wiggles up and down. And in fact, if I can zoom out a little bit, we can kind of see that indeed that's exactly what happens, that the sine function zooms up and up, sine function wiggles up and down. So these are two functions, and I'm going to compose them. I'm going to, that is to say, I'm going to take the sine of g of x. If g is 1 minus x squared, then the sine of g of x is the sine of 1 minus x squared. So what is that? And I'm going to tend to try to focus in. I've chosen these functions so that they aren't always that close to one another. They don't always follow each other, but so they're not close to each other as such, but they're actually close to each other in the sense that they're in this box of this square box of size 1 by 1 near the origin. Um, and in fact, I'm going to be tending to compare them at a couple of points where x equals zero point 0.2, x equals zero point 0.3. I could put these two lines closer together, and in calculus, we take the limit as those two lines get infinitesimally far apart in order to compute slopes, that is to say, derivatives and the like. And I have those as references, but I'm not going to keep those highlighted right now. But let's actually look at what the composition is. The sine of 1 minus x squared, or the sine of negative x plus 1. And we see it actually tends to follow pretty closely at first to 1 minus x squared. But that's also, again, it's kind of cool. If we zoom out, the function itself, that our composed function actually is kind of cool because it wiggles the frequency, as it were, of the function increases as we get further away from the y-axis. And so it's a kind of a cool function, but it also has the feature that it's not exactly the same as either of the two functions that it's composed out of, but it's still kind of within this 1 by 1 box near the origin. And so this is sort of our starting point. We are interested in understanding, being able to compute the derivative of f of x, that is to say, the sine of g of x, that is the composition of g of x, and also we've defined sine of x as h of x. So the composition, this green line is the composition of the blue and the red line functions, and now we would like to be able to figure out the derivative of that function using what's called the chain rule. And so that's what we're going to do, or at least begin to do next time. But this is the setup of an example, and we'll talk to you next time.